Okay, so today we're going to start talking about, like I said, I put part one because, like I said, we're not going to get through today's lesson, but we will start off about talking about special factors. And this first type of special factoring that we're going to talk about, which we already spoke about last class, is dots. And this represents the difference of two squares. Which looks something like a squared minus b squared. And if we're going to have a squared minus b squared and we want to factor it, it becomes an a plus b and an a minus b. But with dots, just like with all other factoring, what do we always look for first? Always look for what first? A GCF. Put a little star. Always look for a GCF first. Okay, so now what I want us to do, my directions are just to factor. And the first one we have is 4x squared minus 100. And because it's only two terms, I know the only type of factoring this could possibly be right now in our arsenal of information in our heads is a dots, because everything else we've learned has three terms. Only a dots has two terms. And I look at this, a dots means difference. This is a difference. This is a subtraction problem. And then two perfect squares. And this is absolutely two perfect squares. 4x squared is a perfect square. 100 is a perfect square. But I would be wrong if I went into a dots right away. Can somebody tell me why would I be wrong if I went into a dots right away? Enged? Good, because there's a GCF and we always have to pull out our GCF first. So I'm going to pull out a GCF of 4, and then I'm left with x squared minus 25. And now I look inside my parentheses and I ask myself, okay, inside the parentheses, can I factor further? Absolutely. Is x squared minus 25 a dots? It sure is. So this is going to be a 4 times the quantity of x plus 5 times x minus 5. And now this is factored completely. We never want to think that we're done factoring. We always look inside our parentheses and ask ourselves, can I factor this more? And the telltale sign that you're done is if the exponent on the variable is 1. If the exponent is higher than 1, we're going to see. We're going to take a minute. We're going to hesitate. We're going to say, can I factor this more? All right, next one. A to the 8th power minus 16. So we look first, is there a GCF? No. My only option, because it's two terms, is a dots. Can I dots this? Can I factor this using dots? Absolutely. A to the 8th power is absolutely a perfect square. What times itself gives me a to the 8th power? A to what power? The 4th power. So we're going to have a to the 4th power, a to the 4th power. What times itself gives us 16? Ira? 4. So we're going to have a to the 4th power plus 4, a to the 4th power minus 4. Remember, you never think you're done. You always look further inside your parentheses and ask yourselves, can you factor further? A to the fourth plus 4, can I factor that again? No, how come a to the fourth plus 4 isn't a dot, even though they're both perfect squares? Yeah, because it's a plus sign. Remember, D, difference. It needs to be subtraction. So this stays as it is. But a to the fourth minus 4, I can factor that further. This is another dot. This becomes a squared plus 2, a squared minus 2. So now I look again at my parentheses. Are any of these another dots? Can I factor anything further? No. A squared minus 2. 2 is not a perfect square, so we leave it just like this. Okay, so I look at this, there is no GCF, but I can factor this using dots. So this becomes 3x to the what? M, 3x to the m minus 5y, and then 3x to the m plus 5y. Same process. All right, so here we have x plus 5 quantity squared minus 25. All right, this is a dots. Why is this a dots? Charlie?
You could just sort of treat the binomial as a singular figure because that's squared.
Yeah.
That's being subtracted by another square.
You got it. So remember, dots is a difference of two perfect squares. Now, inside the parentheses, even though it's a binomial, x plus 5, that quantity is squared. So it's almost like saying if we let, and if you wanted to do this, you could let x plus 5 equal m. This is going to be m squared minus 25. Wouldn't I put an m in one parenthesis and an m in the other parenthesis? It's the same idea. That x plus 5 is quantity squared. So when we come to factor this, it's going to be an x plus 5 in the front. That's sort of like my first term there. And then we do a plus 5 and a minus 5. Do you think I'm done here? No, I can simplify inside these parentheses. 5 plus 5 is 10. And what happens with a positive 5 and a negative 5? They cancel right out. So I'm actually going to put that x in the front over here. So x times the quantity of x plus 10. If you were to write this as x plus 10 times x, I'd be fine with that. Same thing. Do we agree this is another dots? Yeah, because we have two quantities that are squared. So this is absolutely a dots. So now in the front of my parenthesis, I'm going to have an x plus and an x minus. But this is really important. When we come to write the y plus 6 in the minus, what do I need around the y plus 6 and y? Violet? Parentheses. Why do we need the parentheses? Yeah, because we're subtracting the whole quantity of y plus 6, not just the y. Now, I don't really need the parentheses with the x plus because there's nothing to distribute, but I put it in there just to be safe. So now in the first parenthesis, it's x plus y plus 6, nothing to distribute there, so I just lost the parentheses. In the second parentheses, I have to distribute in that minus, so it's an x minus y minus 6. Okay, you guys try this one on your own. Thank you. Okay, so what should we have gotten? Can anybody walk me through this? Ariana? No, walk me through how you did it.
And then it just, so it's like gonna be like F plus R and
Perfect. We have to distribute in that negative, so it's 8x minus r plus 5. Perfect. Now, on the test, you do not need to show me this middle step. If you go straight from this to this, you're fine. You don't need to show me that middle step. Okay, so now we're going to talk about difference of cubes. This is something new. You have never seen this before. So if I have a to the third power minus b to the third power, and I ask you to factor this, you're going to end up with a minus b times the quantity of a squared plus ab plus b squared. And just to show you that this works, you don't have to do this. But remember, when we're factoring, I'm giving you the product and I'm asking you what multiplies to this product. So I gave you the answer of a cubed minus b cubed, and I'm saying what multiplies to that. If you multiply this back out, a times a squared is an a cubed. A times a positive ab is an positive a squared b. A times b squared is an ab squared. Then we're going to have the negative b. So negative b times a squared is a negative a squared b. Negative b times ab is a negative a b squared. I don't know why that did that. Negative, try this again, negative ab squared. And negative b times a positive b squared is a negative b cubed. When you go to combine your like terms, I have a positive a squared b and I have a negative a squared b. They cancel out. Then I have a positive ab squared and a negative ab squared. they cancel out. So I am left with a cubed minus b cubed, just to show you that this works. Okay. So moral of the story is, if we're asked to factor cubes, a cubed minus b cubed will factor into an a minus b times an a squared plus ab plus b squared. Now in dots, when it's the difference of two perfect squares, we're only allowed to have a difference. We don't only need to have a difference for cubes. We can factor a difference of cubes and a sum of cubes. So this was the difference. This will be the sum of cubes. To factor the sum of cubes, I have a cubed plus b cubed. So this gives us an a plus b times an a squared minus ab plus b squared. Now, just to show you, you don't have to write this down. I'm going to multiply this back out. A times a squared is an a cubed. A times a negative ab is a negative a squared b. A times b squared is an ab squared. B times a squared is a positive a squared b. B times negative ab is a negative ab squared. And b times a positive b squared is a positive b cubed. You look for your like terms. I have a negative a squared b and a positive a squared b. They cancel out. Then I have a positive ab squared and a negative ab squared. They cancel out. So we are left with a cubed plus b cubed, just to prove to you that it works. So when we have the sum of cubes, and we're asked to factor, we're going to have a cubed plus b cubed will factor into a plus b times a squared minus ab plus b squared. Okay, let's do some problems. So let's say I have a cubed minus 8. Now, because it's only two terms, we have two options. We have dots or we have cubes. These are our options because it's only two terms. I know this isn't a dot because it's raised to the third power, not squared or a multiple of 2. So this is the same as saying x to the first raised to the third. And is there any way I could make 8 into some base raised to the third power? Anish? You got it. This is the same. Yep, this is 2 to the third power. So remember, this is our a cubed minus b cubed. Do we all agree our a is x and our b is 2? So be careful. Our b is not 8. Our b is 2. Our b is the quantity that's being raised to the third power. So that's the 2 that's being raised to the third power, not the 8. And when we come to factor a difference of cubes, you get a minus b times a squared plus ab plus b squared. So my a is x, so I'm going to have x minus my b is 2, so it's x minus 2. Then we're going to have x squared plus 2x plus 4. And I will tell you, when you're finding the difference or sum of cubes, that trinomial will never, I won't have it be able to be factored. You won't be able to factor that. So meaning when you look at this, there's no factors of positive 4 that will add to positive 2. The only things that multiply to positive 4 are a negative 2 and a negative 2, which will never add to 2, a positive 2 and a positive 2, which will never add to 2, and a positive 4 and a positive 1, which will never add to 2. Yes.
Is there a reason it will never be factorable, or will you just not give us questions where it is factorable?
So I will not give you questions where it is factorable, not factorable. We could always, like when we come to solve, we'd be able to use the quadratic formula, but it won't ever be something that we can just set up because we're factoring this, meaning I can't break it down any further. So this is as much as we can do that. We'd be able to solve, we just can't factor this any further.
Like, so you would never get a question where that trinomial could like,
I never like to say never. It might be. It will never come up in my class where that trinomial can be factored further. I don't know if it will never, ever, it could never happen. I don't know about that. Okay, next one. Okay, so here I have 1000x to the sixth plus 27y to the third. The rule hasn't changed. When it comes to factoring, we always look for a GCF first. Is there a GCF here? No, there's no GCF. I know this isn't a dots. How do I know right away this is not a dots? It's not a difference. It's a plus. So now we have two terms. It's a plus sign. My only option is sum of cubes. Two terms and a plus sign. Only option is sum of cubes, which means I need somehow to make it some quantity A raised to the third power plus some quantity B raised to the third power. Okay, well, we could figure this out. What quantity raised to the third power will give us 1,000? 10, very good. And what quantity to the third power will give me x to the sixth? X squared, you got it, x to the second. Oh, sorry. So I'm going to have a is equal to 10x to the second. All right, what quantity raised to the third power will give me 27? 3. And what quantity to the third power will give me y to the third? Y. So my a is x squared, my b is y, 3y. So now when we come to factor this, sum of cubes, it's going to be an a plus b, and then an a squared minus ab plus b squared. And now let me plug in for a and b. So this is going to be 10x to the second plus 3y. And then we're going to have a squared. A squared is not 10x to the second. A squared is going to be 10x to the second quantity squared minus AB, so minus 10x squared times 3y plus b squared, which is 3y quantity squared. So now I need to obviously simplify that second set of parentheses more. What's 10x squared? What that quantity squared? What does that become? Amanda? Careful, not 10x. You got it. 100x to the fourth. 10x squared times 3y gives us a negative 30x squared y. And then the quantity of 3y squared gives us 9y squared. Okay, sometimes the binomial can be factored further. Sometimes the binomial can be factored further. So I'm going to look at it, 10x squared plus 3y. Can I factor that further? No, the only option there would be a sum of cubes, and 10 and 3y, none of them could be made into something cubed. So I know I'm set here. Try another one. Okay, this one looks more intimidating than it really is because of the m, but isn't this just x to the m raised to the third power? So our a is x to the m. And what is our b? Yeah. So now when we have an a minus a cubed minus b cubed, we're going to get an a minus b times a squared plus ab plus b squared. So our a is x to the m minus 2, and then we're going to have an a squared. Well, what's x to the m squared? X to the 2m plus ab, which is 2x to the m, plus b squared, which is 4. So I look at my binomial x to the m minus 2. I cannot factor that any further. Okay, x to the 6th minus 1. Well, what can we make x to the 6th to raised to the third power? X to what raised to the third power gives us x to the 6th? X to the 2nd. And people always forget this. 1 is a cubed. Can I take 1 to the third power and it's still 1? So that is a cube. So now I have an a minus b. And I'm going to factor that into a minus b times a squared plus, a cubed minus b cubed is what we have. We're going to factor that into a minus b times a squared plus ab plus b squared. So my a minus b is x squared minus 1. And then I'm going to have, be careful, a squared is not x squared. This is going to be x squared raised to the 2nd plus ab, which is just x squared, plus b squared, which is just 1. What's x squared raised to the 2nd? X to the 4th. Am I finished? No, remember I said sometimes we can still factor the binomial. Can I factor the binomial here? Yes, because what has this become? A dots. So now we're going to have an x plus 1, an x minus 1, and then x to the 4th plus x squared plus 1. Okay, I think I want to stop here. I don't want to go on to grouping because that's a separate category. So I'm going to stop here.